All right, and we are live. Let me just get the link to my stream quickly so I can share it. I am live, right? Yes, I am. It's pretty fucking late. I came back from college at around 7 and then I was with my friends. And like it's in the way of your goals. This is exactly how it does this. You're just chilling a little, like you deserve to chill a little because you've been working all day. And my camera was off. Right, so that's what I was saying. Life gets in the way. You you're just chilling right there because you deserve to chill a little. And well, it's 11:13 p.m. and you haven't done 3 questions of data structures and algorithms like you said you would, and you're off track now. Well, what are you gonna fucking do? You're gonna log the fuck back in, get that grind mode on, and that's exactly what we're gonna do. So 3 questions. I know I left an easy question right there in front of my eyes because I was done with 3. I'm gonna start with that because I'm very sleepy and I just wanna get this over with today. Given a string as containing these characters, determine if the input string is valid. An input string is valid if open bracket must be closed by the same type of bracket. Right. Create a stack. st. I'm gonna name it brackets. I heard of a story where the guy got rejected from an interview because his variable naming wasn't good enough. That's not something I'm gonna go through. I is less than s double length I plus plus, and then if si is equal to char c is equal to s of I ch equal to this, or ch equal to another open bracket ch is equal to it's just gonna contain these characters, right? Well, if it's an open bracket, you add it to the stack. If you find that it's a closed bracket and the top of the stack is equal to the open version of it, you pop both of them, and in the end, you check if the stack is empty. If brackets not empty, if it's true, then you would return, and you can just return this function itself. Return. Right, if it's an open bracket of any sort, then you brackets dot push back sfi if ch is equal to okay. So if it's an open bracket, it adds it, and if brackets dot top to access top stack in CPP. Oh, I forgot to open the chat though. I'll do that quickly. Um, why why can I not see the chat? Chat. Something went wrong with the chat. I don't like that. Um, Hi chat. Man, mad respect for what, friend? For tuning in and solving easy ass questions. Right, as your top, it's a method, not an object. Brackets or top is equal to rev ch brackets dot pop. So if this is as you just return false because that's a case that can never happen, I think. Yeah, it's a case that can never happen. So this should take care of all the cases. All I need to do is set up a map of char and char called rev equal to this. I'm just gonna open this. All you like exhaust should decide to stay counter to goals. There aren't many people out there who do that. And we are gonna be one of them. I'm getting a call from my mom. Just a second, I'll go check what's up with that. Be right back. Hello. All right. I'm back. Just I think I increased my volume a little bit too much. Is this okay? If are you there? Can you tell me this is okay? Oh God, I need to get this mosquito. Bro is who the fuck is watching the comment at least? Yeah, I'm perfect. I'm too fucking perfect. Pop the chat out. It's fine. Gonna keep the volume just like this. And I want it next to my WhatsApp. All right. And switch the scene back. Right. Create a map. Store the corresponding. I should just do this and then change them. Right. Oh, I did it the opposite way. It's gonna be this and this. Right. Should work. Brackets dot push back in. Okay, yeah. You can't push back. You just gotta push. Huh? That works. And a seg for if I do this. Okay. Character is not any of these. We're gonna run this if brackets dot top stack is empty. Should not be empty. So if it's not, it's gonna return false and then it becomes true. And this test case should be passing now. So these test cases, if you don't know, these are like small problems that your code can run, small hoops that your code can run through. And when you click on submit, there's thousands more of these hoops that your code runs through. And that is a solution. And we're done with this question. All right, save it to the sheet. Pretty sure I can solve this again. No need for remarks. Implement min stack. Delete cookies and restart. What do you mean? Holy fuck. Did they just go through? Just sign in again. Yeah, okay. Implement min stack. Where's my chat? Right. So your cooking services are fine as fuck. They are. They what are you even on, man? The eggs he cooked. Oh, that, yes. Tanish missed that out. Completely missed that. Design a stack that supports push, pop, top, and retrieving the minimum element in constant time. I've already solved this. I don't remember though. Implement the min stack class. Push, pop, top, minimum element in constant time. Min stack initializes the stack object into I'll push the element back onto the stack. Pop removes it from the stack. Top gets the element. Get min retrieves the minimum element in the stack. Implement a solution with O time complexity for each function. I think it's pretty easy. All you do is each time you push into the stack, you compare what. No, but if you push out the minimum, then you need to place it with the. Okay, okay. Okay, I need to. So I've got a stack, normal stack, and I need to retrieve the minimum element in constant time too. Right, so I'll just create. I don't know why I'm thinking of a linked list. So what I'm thinking is, right, so there's this normal stack that you have, and there's a node. And every time you push onto the stack, right, you push this block onto the stack, you compare it with the minimum, and if it's null, you just create a new node and create and make it the minimum. So suppose it's x and this is x. You push on y is greater. Now you don't do anything when it's greater, because then if you pop it, you get the minimum anyways. Pop it, the minimum doesn't change. If you push on an element that's smaller, that's z, well then you make z point to this and you make this min, right? And if you pop z, then min becomes this. It's next. You can't pop this without popping this, so it's irrelevant. Okay. Uh, why are you guys talking on fucking WhatsApp? Are you guys here? You better be talking on the chat if you're online. All right? I want a lively chat. Yes, that's better. It's because, all right, so the idea is that if you see a guy streaming and he's got 0 viewers, well, you're not gonna fucking join the stream, are you? I mean, you might send him a message or two, you might reply, and then you will leave. But if it's a lively chat, and he's got something to read, he's got people to interact to, right? Like imagine what if a do lip bite, dude can't text all this BS here dog, you know you cannot. Year two, yes, why? I can bite my lips, that's fine with me. Alright, so I was thinking that I'll just implement a linked list. If you guys want to know what a linked list is, I can tell you what a linked list is. And then you can solve these questions with me and maybe find it interesting. Or not. Natural is better. What do you mean natural is better? ये तो fake लगी. Oh, I know. I do a natural lip bite when I don't know why I do it, and when I do it, you'll have to notice it for me. Um, Create a linked list. Does the STL class have a linked list? In the list. Are the methods? Yeah, well, what are the methods on the linked list? Are you studying, Tanishq? Push back, push front, pop back. I'm working. Yeah, that's okay. Got it. I got it. Pop front, pop back, insert. It is clear, remove, unique, front, back, empty size. Sort, reverse, merge, splice. Or you can just do pop front, right? So how do you create it again? It's list. Okay. List. Get the right indentation because it's very weird without it. Min. If min dot size equal to 0, min dot front. English only chat. You can't tell me nothing. No, you can talk in Hindi. I think that's fine. I think everybody who joins this stream already knows I'm Indian by the virtue of my fucking door and my accent and something. Well, I don't know. I mean, not okay. So if the size is 0, well, then you automatically push it to the front. Right? Yeah, who you fooling? I ain't fooling no one. No one. Val is less than min dot front. What was I doing? So if it's less than, if it's equal to 0 or it's less than, then you add it to the front. Min dot push front val. Just like implement stack object, push element val onto stack. I can just use a stack. Do I have to use like an array for this? I don't think I do. So I'm just gonna do this stack and st. Means stack does nothing. And then you do st dot push. Well, right? That's it. And you're popping in st.top. I need to put an equal to statement because there can be multiple of the same ones, right? You still need to push it. If st.top is equal to, if it's equal to, well, what? Well, you can still just follow this rule and improve our shit. You can even join me in my streams, actually. That's something you guys can do. If st.top is equal to 3 watches, see? Now someone can interact with you guys. Hi, who is the third person watching? So st.top is equal to, how can join? Now that is good use of the internet. You're not wasting any bytes here and there. I think we can start a Discord channel and we can all join there. You can study and stream. That's something you can do. I mean, we can do. So if wait, so if st.top is equal to min dot front, then you need to pop min dot pop front. St dot pop in top st dot top. You just return that get min return min dot front. Let's try and run this. The work is usually on notebooks, so kind of strange for us to join people, see our hair as nothing else. That is true. This is specific, and this actually ran. I'm not sure this is the most optimal implementation, so I'm using a linked list, but it did run. Let me just ask ChatGPT, is this the most optimal solution for Instack? Another solution that I could think of was you just use another stack. You can use another stack, right? Separate my list to track the members that we unless the correct approach. Select a couple of refinements could make it even more elegant and space efficient. Use list and to track min values, keeps all min that are active, post only on the current top equals the min trade-off, might use a bit more space if multiple duplicates of the current min are pushed. Yeah, is a single stack of pairs. Oh, oh yes, you can do that. Custom stack using dynamic array or vector. Right. That's another thing you can do. Already optimal in terms of time, complexity, and good enough for interviews, contests, and real use. On make it in clear stack of pairs approach. I was thinking of something like that, but I was thinking of another data structure that stores the minimum. Alright, so this is one solution. I want to save this to my sheet. Uh, Two approaches, couldn't think of the other one. All right. So if I reset this code, and I see a mosquito A. B, I can. So I need to set a pair. Let's get a private space right here. And min create a stack. Stack should store a pair of int push this value into the stack if st dot size is equal empty or val is less than min. This min is equal to val st dot push back a pair of the val comma this min. The issue there. Yep, everybody's here. Interesting stuff. But well, when you pop, you pop. St dot pop, easy. Get the top st return st dot top. So if it's empty, then this min is set to val, or if val is less than min, then this is set to min. And you get the minimum this way. So this should be another implementation that works. Ah, always this pushback. And is this even a valid code? Script. But you should study your work. Read the earlier chat, man. I'm on break today. 05 was done. Lol. Script pop. Lol. Where he says pop, I go like script pop pop. There is a lot of popping in here. And I forgot a colon. Works. And if I submit it. So this does not work. Interesting. Minus 20 for some reason. Hmm. And my eyes. And I'm gonna go get my eyes tested tomorrow. First thing in the morning. Does anyone else wanna check what their number is right now? ChatGPT is a joke. I won't join you. What happened to ChatGPT? What GPT chat are you guys talking about? Okay, got you. I wanna. Int management. It's not getting pop. Right. Forgot about that. Scroll up, read my long text. Um, Scroll up where in this chat? I don't see anything in this chat or WhatsApp. Oh, each chat GPT search or question costs you rupees 0.203. Will not you will like open AI this much? Or don't ask me how did I calculate this. I'm gonna do exactly that, and I'm gonna ask you how did you calculate this? How this implementation works too. Run with two topics and learning about stacks and queues. So I'm gonna move on to another question. Recursion hard. Oh God. I got so fucked by these questions yesterday. 0.023. Calculate the amount of electricity it uses for one response and then just do some multiplication. Um, well, I don't really give a fuck about these corporates as long as it's not money out of my wallet. Why do you wanna care though, right? It's not your money. If you get it for free, you get it for free. Someone's money is burning, at least let someone's money burn. Given an m by n grid of characters, word, and a string of words, and a string word. So we've got a 2 by 2 grid of characters and a string. Return true if word exists in the grid. The word can be constructed from letters of sequentially adjacent cells. Adjacent cells are horizontally or vertically neighboring. The same letter cell may not be used more than once. The same letter cell may not be used more than once. Okay. Sam Altman asked users to stop saying thank you and please your ChatGPT because they lost billions because of that. So it's funny, bro. That is actually hilarious. That actually is hilarious. All right, so we've got this right, and we want to see string is ABCCED, ABCCED. So we start here. We look for A's. Find a A. We mark it somehow. So I need to create a vector of vector bool marked. Tanishq, man, he's gone again. At least trying to work on something. So let's let him work on that. Size less than board dot size. And you can work on something you want to, and we can all just chill out and have a fun, jolly time working our asses off. For int j is equal to 0, j is less than board 0 dot size. Does it always, do I always get a board? Let's look at the constraints. M is always less than equal to 1. So it's at least 1, right? Well, I can just create a vector of size j, right? Vector and vec create it as marked. So we've got a marked boolean. Is there a more optimal way? Is there a more optimal create this array? 2D marked using construction vector. Boot dot size, comma. Alright, vector bool. I did not know I could do that. Bool marked boot dot size vector. That's exactly what we did, right? That's what I was thinking because that does make it a lot easier. Let's see if it was doing the same thing. Yes, it was. Yep, exactly the same thing. Create marked array. Right, and then we're gonna pass this array to this the helper function. So create a private helper function. And you know what? This chair isn't the best, and I've started realizing that because I've got a pain in my lower back. So all I'm gonna do is stream while I'm sitting here, and I'm gonna chill the fuck out on my bed again. I get all sorts of problems because of chairs, and it's just not real nice. Okay, we got this, and we've got this, and we've got this. My back's aching. Yeah, same, by same. And we get an index to keep track. And if this base, I don't even think we need the base case. So we're gonna move from root setup. I'm on a full wooden chair with zero cushioning. Oh, my bad, bro, my bad, completely my bad. Right, so for each letter in the array, so suppose we start from here. So index is actually a pair, right? Because then we can't track if it's not a pair. Quickly create a pair int comma int called index. Chairs are bad. Now bro is just throwing a blanket statement at the world. So we choose this and then we mark it. And then we create another function call. We increase this and another function call. We increase this. Whoa, 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 whoa. Right. Each time we choose string, we can just check if it's creating the right string. Right word. Make it string current. We start at 0, 0 down, and then we've got this option. We've got 4 options. I'm just gonna create it an escalator. Right. Suppose what is the 4 and 3 rows? Plus 3 rows and 4 columns. So we start at 0, 0, right? And then we've got the same thing, except we're gonna mark it. This is our marked array, right? We'll do this. So we start with 0, 0. We mark it, and then we check if this is marked. It's not. Well, then we create a function call with this. Right, okay, so we create a function call with this. I'm not gonna write this, I'm just gonna write 0. So this calls 0, 1, and then we go down here, we check if it's true, and this creates a call for 1, 0. 0, 1 has got this, so it obviously marks itself, and then it goes towards its right, and then creates a call for 0, 2, and each time we're gonna update the string, and if the string current is not equal to the substring, then we return and we don't create further calls, right? And we got to start at each index. So once you're done with this, and this, create a call for this. Okay, so this returns a bool, and if curve is not equal to word dot substr 0 comma curve dot size curve dot length actually, when you return false. If curve is equal to word, you return true. And right here you do the recursive calls if uh, you start. Right, okay, so you go up top first, top, left, right, bottom, left. So to go to the top, if index dot first is greater than 0, still on the bed, bro. Sit on the bed. I will. This is the last question. That's kind of fucked up. If it's 0, that's the only situation that where we can go to the top, right? It should be at least 1. Then um okay, first mark, that should not be this, marked index dot first, index dot second. Well, you gotta mark it regardless, right? So I'm gonna do that, equal to true. Mark index dot first and index dot second is true, and then you move towards the top and you call the helper function with the board, the word, the marked array, uh, index dot first minus equal to 1, index, and the one this is called, this will mark true. This will mark true, and then curve plus equal to word, uh, curve plus equal to word, and then what's the index? What's the index of the word we're at? We need to make it the board. Index of first, index of second. So curve, so we add a. If index of first is greater than 0, index of first is minus equal to 1, board, word, marked, index, and the current. Right. And then you backtrack. Right, to move right, then uh, index dot second is less than, so this is the row. To move right, move zero size. So the length of the first array match, and that should be, it should be less than that. Then index dot second plus equal to 1. Similarly, minus equal to 1 because of it, because we're going to backtrack. Call the helper function with the board, the word, marked, and index, and then current. You go to the bottom. If we're at the bottom, if you want to go to the bottom, then you can't be at the bottom, right? So it can't be index dot first is index dot first is less than word dot size minus 1. Index dot first and to move towards the bottom, you need to add 1. And if you want to move left, right, so this is a starting point, and then this can be another starting point, and I'm gonna just right, int I equal to 0, I is less than board dot size, for int j equal to 0, j is less than board 0 dot size, j plus plus. If board I j is equal to word 0, that's if matches, then you call this helper function. And to move left, you need to check if you want to move left, then you must be index dot second should be greater than 0, right? Yeah. And then you index dot second to minus equal to 1. And then the next, to backtrack, you do plus equal to 1. And then you do helper board, word, marked, index, and current. And you do board, marked, word, It should be 0, 0. It's not 0, 0. It should be I, comma J. The word is always nothing in the start. I think that I should do these first. And these return a value, right? If these, then you return true. And similarly, if this happens, you return true. Hey, new two people, can we at least get a hello for watching? That's crazy. Hi guys, we got 4 watching now. All right, so I think we're done with this recursive solution. We've already marked this. Mm, This gets added here. This gets added here. We check. All right. If this returns true, we return true. And it's in the end, we return false. Let's try this. Not no viable overload operator for vector vector board. Um. Okay. Board dot size vector board. Should have worked. And function not available. Ah, yes. Board is not a 2D vector. Board 0 does not exist. Board is always going to exist. Board. If you're using this inside a class method, make sure board is in scope properly typed. It is. Bro, always relate to your titles. What's the title today? Isn't it? I don't want to do this anymore. Crazy. All right. So I don't want you to tell me the answer unless I ask for it. Look at me wasting OpenAI's money. They've be a teacher and tell me what I need to nudge the right direction. Is there a problem with the way I create mark? Gotta sleep, man. When we ending, yeah, a map. Not gonna sleep today. We'll study whole night. Are you really gonna study for the whole night, Prashast? You're passing marking to a value, not by reference. I know. What I was changing my to mark inside one column. That's by design, bitch. Assignment operator misuse. This is a comma separator. Oh, oh God. How can I make this mistake? How can I make this mistake? No way I did that. Oh, I'll confirm this to string. Parent board word marked index कर board word marked board word marked index कर. Oh, crazy! I'm getting the correct solution in two cases. I'm so happy with that. ABCB returns me ABC ABC. So it should be done false. Goes here, marks A. You fix this and equals to works in marked by values creates a copy on each recursive code. This means that the cell is marked as visited. Its state isn't preserved across recursive levels. Well, and how is that bad? So it's true. And then you get this marked and you get another one marked. I don't wanna this what the I did. We did check missing. Oh God, yes. I added the visited, but I didn't check it. And marked index dot first minus one index dot second. If it's true, now reduce it. So make it false. If index dot second and I want to move right mark marked and we need the opposite of it. If it's moving right, then index dot first stays the same. index dot second plus 1. So marked index dot second plus 1. How the fuck? Um, will not study shit. Who am I lying to? Will not study shit. That's much more believable. That's not true, actually. I wanted to finish everything early today. It's already 12:23. Oh God. Although this is the last question, and the last two questions I did were easy. I just I think you can do it for the whole night. But the thing is, what are you gonna study for the whole night? It's better get if you just plan your, month out right now. If you really feel like you should do something and you just got scolded from your dad and you feel like you should start working, it's better to actually create a plan that you're gonna stick to right now because you're real in the moment and get a good night's sleep and start tomorrow and take it day by day. Just one night will not change anything. Do it fast, man. It's like you're waiting so that you can go to sleep. It's so nice of you, but this is a tough question because it's got 2D arrays and stuff. Index dot second plus 1. Yes, check that. Another check right here. So let me go and letting me go. Fucking work. Index dot first plus 1. Index dot second and marked. And I think ChatGPT is wrong. I don't even need to pass it by value. I like pass it by reference. I think my implementation is correct, but we'll see. Index dot first, index dot second minus 1. Okay, let's see. And if I submit the code, time limit exceeded. Ah, hate this. Fucking hate this. So why is it taking so much time? It should just keep going to the right and form. I need to optimize this. I don't know. I want me to pass the marked arrow by reference. It's gonna mess the solution up. That's a very sharp observation. You're absolutely right. The pass by reference of value depends on how you're managing backtracking. Passing marked by value, which means every recursive call gets its own copy. Changes like marking cell true doesn't reflect the call, so no need to unmark anything. Each path has its own state. But it's memory heavy, especially for deep recursion on large boards. Avoids copying the marked matrix each time, but then you need to undo your changes, backtrack before returning. Huh, right, you do. So you can do that. You can do that. So I guess it does work if this is marked right here, and then I turn this into false in the end, and then I pass it by reference. Then it should work with this too. That's nice. Oh, is this a trick used commonly to save memory? Everybody's sleeping. I'm getting hearts in the chat. Board problem is small. Pass by reference, manual undo. Less memory, faster. Must be very careful to understand probably. So it's basically just you need to use more of your brain and it uses less memory. So it's a good thing. So that's what you should do. Right. That's what I did. It's okay. But I'm getting a time limit. So if I do use this test case, I'll get a time limit exceeded. No, I don't. Really? A, B, C, D, A, C, D, A. And I'm getting a false for that same reason. You nailed the backtracking version. This is clean, correct use position. Okay, tiny option. Right now you're building a curse string on every recursion. This works, but do you really need the whole string every time? Can you track the current index in Word instead and just compare the characters directly? It'll reduce string operations and improve performance. You can track the current index and instead just compare characters directly. Hmm. You can. I can't. A, B, C, D, only one. Try tracing it. A, B, C, D. What is A, C, D? A, C, D, B. Uh, right. A, C, D, B. Yes, this is a valid path. Cur is not equal to a substring. You're still building and comparing strings. This is a costly and risky way to match characters. You're reconstructing slicing strings every time. Try tracking the current version. Okay. Okay. It's just so many variables I need to keep track of. And okay. And we pass in 0 right here. And to add this every fucking where. Every fucking where. And after this, if cur is not equal to is greater than equal to. So if I want the last character, last index, I will string in this, not in this, you fucking cunt. We can't solve this. No, I cannot. I don't feel like I can though. Ah, see. Um, then you ending. The fact that I cannot solve this does not mean I can stop. That is the point of studying. The point of studying is you fail and you learn, not that you stop. So I need to finish this question. 95 perfect. K toward building substrings. Still building curve. Yeah, why am I still building curve? That's what I was thinking. Can remove that. Stop yapping, stall the damn question. Why stop yapping? I'm a doze off, bro. I'm a fucking sleep. It's this late and I'm trying to fucking use my brain. Yeah, I don't need this. Mark this index as true. And then I just don't want to see curve anywhere in here. Remove this. Right, 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 right. Works, works. If I submit this, the logic is still the same, though it won't work, right? No, it won't work. I was here for the vibes. This is a desolate desert with scorching sun and data structure with for days on end. There are no vibes here. If word index or first measure segment is not equal to word k, it's currently restricted. Holy fuck. This is exactly the sort of thing I should have not done. Classic recursion pattern. The base cases are at the top for a reason. That's what I got to learn today. Don't tell me that if I... Oh God. Really good question. Ugh, I did spend 50 minutes on this question. Ugh. Further optimization, early termination, already terminus early for match fails. You can make this search smarter by not exploring unpromising direction. If there are no characters left in the world, you can stop exploring a certain direction earlier. Optimizing the board size checks. Ended row, no. I gotta fucking optimize the solution, bro. What are you on about? This is not stopping. This is not stopping at all. You're not checking bounds like if index.first is greater than 0. Slightly clearer code would be index.first is 0 and but you ensure to handle boundary conditions pruning early if there are other cases where the word cannot fit based on remaining with pruning with extra checks. If you know some letters appear more than once, you can prune paths. Huh? Where the word cannot be constructed. I'll have to watch a video on this. This is a really nice question, though. This is a really nice question. I'll take that, mark that with a star. It's really that good of a question. Oh, there is no dopamine hit. I'm so fucking sleepy. There is no dopamine hit. Man, what's it called? Word search. Oh God. Word search backtracking. Word search 2. There's a second part to this question. Fucker. I hate leetcode. Why is there a second part to this question? Why the fuck is there a second part to this question? Oh, I'm gonna be coming here again. That's not okay.
Pretty good problem, and it's definitely very popular. So we're given a grid
Alright, are you
m
guys
by
ready for
n
this?
with a bunch of characters.
I think my sound's off. I'll need to check. Yeah, now it should work.
Or you could say it's a board, and we're also given a target word, and
I
we want
get it.
to look.
I get if you wanna leave. It's a completely fine and reasonable thing to do. But there's just 10 minutes of this and then I'm done. Just 10 more minutes of this. Alright, good night.
For this word inside of our board, and if we can find the word, we return true. If we can't find the word, then we return false. And so within our grid, the word can be constructed any way, but it has to be either horizontally or vertically neighboring cells. So basically what we're looking for, let's say this is our board, we're looking for a path inside of this board where we can move horizontally, right? Where we go to the right, then we go down, and then we go to the left. So this is our path, and we are looking for a word. So we're looking for a path that can make this word. So down here you can see an example. They give us a target word, A, B, C, C, E, D, and that's the word we're looking for. We're looking for a path, and we can find a path with exactly those characters. Therefore, we can return true. Now, the question you're wondering is how can we figure this out? Is there a really efficient algorithm to solve this problem? The answer is no.
You can
There's
go.
not a super efficient one.
So
We're just going to
ready.
go through the brute.
What is it? It's 12:42 a.m. You've stuck with me for almost I don't know how many hours. That's already really great.
Force solution, and that brute force solution is going to be backtracking. So basically, this problem is actually pretty intuitive, right? How would you solve this problem in real life if you didn't have any code? Well, you go brute force, right? Let's start at every single cell. So we go through every single cell, right? Let's say this is an E, right? Does our word start with an E? No, it starts with an A. Now we have a C. Does our word start with a C? Nope. Does our word start with a B? Nope. Does our word start with an A? Yes, it does. So now let's look at all the neighbors of A and look for our next destination character. Our next target character is B, right? So let's look down. We don't have a B over here. This is an S. Let's look up. There's nothing up. Left, there's nothing left. Okay, to the right, we have a B. Great. Now the next character we're looking for is a C. Are there any neighboring Cs? Not up, right? What about to the left? we can't reuse a character, so we can't reuse this A, but we wouldn't want to use it anyway, but that's just another detail, right? We can't reuse any characters. Down here, there's an F, that's not what we're looking for, but to the right, there's a C, right? Obviously, we can see that, and the next character we're looking for is a second C. You know, we could run through this, but it's mainly just brute force, right? We're going through every single position, looking at every single neighbor to see if it's even possible for us to make this target word. In this case, the answer is obviously yes. We have an E, and we have a D, we can finish it up. So in the code, we're going to be doing backtracking, so let me jump into that. Or rather, we're going to be doing recursive backtracking. So we're going to do this recursively, or in other words, we're going to do this with depth first search. So let's dive right into it. So one thing I like to do with these problems is just get the dimension. So I'm going to get the number of rows and the number of columns. So get the length of the board, we get the number of rows, and get the length of the first row, and we get the number of columns. Also, remember how I said we can't revisit the same character twice within our path? Therefore, we're going to need a variable or a data structure for our path. We're going to use a set to add all the current values from our board or positions in our board that are currently within our path to make sure that we don't revisit the same position twice within our path. But other than that, if you've seen any of my backtracking videos, you know I like to follow a formula, so I'm just going to be going through that right now. So I like to create a nested depth first search function within the root or the regular function, because then we don't have to pass in some of the variables like the board and the word, because this is a nested function. But we are going to have to pass in the position of the board that we're at, so two variables, row, column for that. And we're going to have to pass in a third variable, I, which is going to tell us the current character within our target word that we're looking for. So if we ever reach the end of the word, or if I ever equals the last position, so if we ever finish the entire word, therefore we know we found the word, therefore we know we can return true, right? That's the good case. The other case is, what if we go out of bounds, right? Out of bounds of the entire board. What if row is less than 0 or column is less than 0, right? Or what if row is greater than or equal to the number of rows, or if column is greater than or equal to the number of columns? That's also out of bounds. So, or let's consider one more case. What if the character that we're at in our word, so word at position I, is not equal to the character that we're at in our board? So board at position row, column. So if this is the case, if basically we found the wrong character, then we also want to return false. And there's one last condition we have to check. What if the character, or what if the position we're at, row, column, this tuple, what if this row, column position that we're at is inside of our path set? What does that mean? That means we're visiting the same position twice within our path. We know all of these things that I've just listed, all these conditions are basically invalid. If any of these are true, then we have to return false, because, you know, if we're out of bounds, we return false. If we see the same character twice, we return false. If we see a character that we are not looking for, we also return false. Okay, but once we're done with that, then we know, okay, we found the character we're looking for, right? So what can we do? We can take our path and add the current position to it. So the current row, column to our path, because we found a character that we need. So now we're going to be continuing our recursive depth first search. And so we're going to be looking for the result of this depth first search. So we're going to run depth first search, right? We're going to run it in all 4 adjacent positions. So what I'm going to do is say row plus 1, leave the column the same, and add 1 to I. We're adding 1 to I because we found the character we are looking for. Now we're going to look for the next character, right? So now I'm just going to basically copy and paste this a few times. So I copy and pasted it 4 times because we're going to look at all 4 of the adjacent positions. So let me just fix this up. So you probably see what I'm doing, but basically I'm saying row plus 1, leave column the same, row minus 1, leave column the same, column plus 1, leave row the same, and column minus 1,
That's
leave row
really
the same.
nice.
So
That's a really nice way. You don't have to add so many checks.
We're running depth first search on all of them, and if any of them return true, then our result is going to return true. Remember, we only need to find our target word one single time. So if we ever find that word, then we know we can return true. So I'm going to go ahead and return that result, but right before I return that result, I'm going to do a little bit of cleaning up. So I'm going to take our path variable and remove from it the position we just added to the path, because we're no longer visiting that position, right? We're returning from this function call, therefore we don't have to continue to visit that position inside of our path. So this depth first search recursive function is always the main part of the backtracking problems. Once we're done with this function, the only thing left for us to do is actually brute force, go through every single position in our grid and run this depth first search function on it. So that's exactly what I'm going to do for every single position, every single starting position in our board. I'm going to run depth first search, passing in the row column, passing in 0 for the position of I, because we're always starting at the beginning of the word. And if we ever return true, if this depth first search function ever returns true, I can immediately return true from our function exists, right? I can just return true immediately. I don't have to wait. And if we never return true, if this goes through every position in the board and we never return true, then I'm going to have to return false out here, because that means we did not find the word that we were looking for. So this is the entire function. Actually, you can tell that it's definitely not very efficient, right? We're running through the entire board, right? So what's the time complexity of that? Running through the entire board is going to be n times m, because those are the dimensions of our board, and that's being multiplied by the depth first search function, right? Because we're calling that depth first search function every single time for every position in the board. So the question becomes, what's the time complexity of the depth first search function? Well, the call stack of that depth first search function is always going to be the length of the word, right? Because the word can only be so long, we can only go through so many characters for the word. So that's going to be the call stack of it. Remember, though we have 4 different branches. We're calling the depth first search 4 different times, so it's really going to be 4 to the power of the length of the word that we are given. So it's going to be something like 4 to the power of n, where n is the length of the word. So you can see this problem is not very efficient, so let's just clean this up. So this is going to be 4 to the power of n roughly, right? So it's not a very efficient solution. This is the rough time complexity of the problem. So I hope this was helpful. If it was, please like and subscribe. It supports the channel a lot, and I'll hopefully see you pretty soon. Thanks for watching.
This is actually a really neat solution to this. I really like this explanation. All right, we're done with another hard recursion problem. So these are all hard problems according to the guy who made the list. And two more of these stacks problems. Okay, we're done with the learning part of stacks and queues, and we're gonna move on to prefix, infix, postfix, and conversion problems. These are all just fucking videos. I will probably find them on Geeks for Geeks, so that's okay. Send you money. I don't have money to send you. So are we done here? Yes, we are. We are done here. No, this is not torture. This is the way you land a fucking dev job now. This is dumb, isn't it? So dumb. And you guys think this is torture. Wait till you get to graphs. There's fucking 54 of these. And trees 39. Oh God. Okay. And what are you trying to say? And what? And what, Taish? I'm just playing. Alright, so that's it for this stream. Honestly, you guys were here and it was sort of fun, or I would have slept. I would have definitely slept. But I'm in the stream now. Do you guys want to play Minecraft or something?